Hello everyone, this is Cooper here with Milestone Scholars. Today we are going to learn about only what I can describe as a hodgepodge of unrelated mathematical concepts all shoved into one video because I could not find a commonality between them all. Since we don't have a lot of time, let's dive right into it. The types of numbers are natural numbers, that's like 1, 2, 3, going on up until infinity. Whole numbers, which are the same thing as natural numbers, but they include 0 as well, and these are all non-decimal numbers, 0, 1, 2, 3, etc. Integers are like whole numbers, but they also include negative numbers as well, so that would go from positive infinity all the way down to negative infinity. And these don't have decimals or fractions either. Rational numbers, as you can see down here, like 3/5 or 5 counts as a rational number as well, because that can be like 5 over 1, or negative 7.62. These are basically, they're a set of integers and fractions, meaning if you can write it as a fraction, essentially it's not necessarily true, but generally it's a whole number, a rational number, as long as there is an ending decimal, meaning the decimal doesn't keep repeating, and as long as it's or if it's 1/3, for example, if the decimal is repeating, so 0.33333, or if you had any pattern, it could be 0.52525252, for example, that still counts as a rational number. Irrational numbers, however, are those that have non-terminating, or like basically they never end, and they're not repeating, so they don't have any sort of like it's not like 1/3 where 3 keeps repeating. It would be like an irrational number might be 0.52346895 forever. And that is definitely an irrational number. So all of these numbers are real numbers. And what does that mean? Well, it doesn't really mean much at all. It's just those are the types of numbers, really. And you can review these if you want. This isn't necessarily like an essential skill in algebra, but it's definitely good to know. So let's move on. Let's talk about absolute values. So absolute values denoted by these two little bars. So anything inside of the two bars is turned positive, and we'll get why in a second. Oopsies. So if you had negative 12, that actually equals 12. But what exactly does this mean? So say we have an equation, x minus 12 absolute value equals 2. Now we know that either negative 2 or 2 can give us our answer, right? Because if you have those values, then it's going to give you a value of 2. Meaning that if we try and use some logic here, if x minus 12 is negative 2 or if x minus 12 is 2, then we can find our answer, if that makes sense. So if x minus 12 equals negative 2, or if x minus 12 equals 2, then x equals 14, or 10. Sorry, I can't think. So those are answers, and if you plug them in, it's correct. I mean, you can try it yourself. I'm not going to plug it in here. So those are our solutions. So let's talk about graphing inequalities. So we all know about this sort of number line style here. Say this is 0, say this is 3, say this is negative 3. Let's say we have an equality x is, actually let's say this is 5. If x is less than 5, you would graph that with an open circle, as we know it's near 5, but not on 5, and then we would graph it less than, so that would mean you draw this darker line all the way through to the end of this number line. Because any value that is shaded and not in the circle, so not 5, but any value that's shaded, could be a value of x. So that's what we're looking for. Now, if we had a different inequality, I think I might have said equality, x is greater than or equal to 3, right? Then you'd have to draw, since it's the point at 3 counts as well, you draw a dark black circle instead. It doesn't have to be black, but it's just a point. And then you draw it up because it's greater than 3. So it has to exist in these values. That's where x can exist, basically. So now let's try another one. Let's go 5 and 7. Let's try 5 is less than x is less than 7. So if x is less than 7, it means it's going to be, you draw your open circle and you draw it in here. But now if x is greater than 5, you draw another open circle and you draw it in here. So it doesn't extend past any of these circles because that's not where the value of x exists. It never touches 5 or 7, but it just comes near it. So that's how you graph inequalities. It's not too terrible. Let's do a little bit more of the hodgepodge stuff. So a quick note, if we have 4, okay, I did that wrong, 4 plus -6, that is the same as 4 minus 6. So that's something that you need to remember. I can't really give you a good explanation as to why, except it's like saying -6 plus 4. It's going to give you -2 either way, I guess. But if you think about it, if you had 4 minus -6, that means you're subtracting a negative value, so you'd add. So that is going to be 4 plus 6, which is 10, and that is -2. Cool. And then one more little note before we end this video. Let's see, we have -a minus b. It's the same, remember we learned about distribution the other day? So it's the same as -1 times a minus b, which then becomes -a plus b. So, I mean, it's just like distributing your -1. Also, one last final note. A negative times or divided by a negative is a positive. That's definitely important. You may already know this. I'm trying to go over all these negatives and positives now that we're on the topic of integers and things like that. But -5 divided by -5 is going to be 1. And yeah, that's just something that you need to know as well, kind of another rule, but you'll get the hang of it as we go farther along. So, thank you so much for watching this video. I hope you enjoyed it. Sorry that it was kind of hodgepodgey, but just to review, we went over the types of numbers, all these real numbers, and then we went over and talked about absolute values and how to solve those equations, and then we went over to graphing inequalities, and then we went all the way down to some of these rules about adding, subtracting, dividing with negative numbers, and distribution. So I hope that was helpful. Thank you so much for watching this video, and I hope you have a great day. See you later.